Hey class, this is lesson 531, special products. We're almost done with this lesson. Just a couple of things that you may or may not have noticed. There's some patterns in multiplying binomials together, and we're going to look at some of those patterns and kind of their little shortcuts. And also, if you think about these, they can help you do some mental math pretty quickly. So, two things. We're going to look at patterns of where we have two numbers added together as a binomial and we square that, and also when they're subtracted and we square that, and also where you have two binomials, one where you're adding but have the same two terms, and one where you're subtracting. So, and you need to recognize when those happen. So just to kind of look for this here, we'll explore these patterns. If we multiply out, expand x plus 1 squared, that's the same as the quantity x plus 1 times quantity x plus 1. We're going to end up with x squared plus 2x plus 1. If we expand x plus 2 squared, we get x squared plus 4x plus 4. If we expand x plus 3, the quantity squared, we get x squared plus 6x plus 9. And I'm going to just skip to the answer here. When we multiply x plus 4 times itself, we get x squared plus 8x plus 16. Now pause here and just look at those numbers. Compare this number to these two numbers in each case, and see if you don't notice the pattern. But pause here and think about it for a second. All right, what you should have noticed is that this 4, if you square 4, you get this number, 16. And if you multiply 4 times 2, you get this number, 8. So if I want to use that pattern here to expand the quantity x plus 10 squared, I know that when I multiply x by itself, I'm going to get x squared. The middle number, though, is going to be this 10 doubled, so 20x, plus the last number will be 10 times 10, which is 100. And just one more quick example like that. Let's say we have x plus maybe 30 squared. So we're going to get x squared. If you double 30, you get 60, so it'll be plus 60x. And then if you multiply 30 by itself, you get 900. So that would look like that. All right. So you can go ahead and apply that pattern that we just discovered there in these. We can do that in class. And let's move on and look for some new patterns here. All right, it says apply the pattern to predict the expansion of x plus a. Now remember, the first term in our answer, it's going to be a trinomial. It's going to be x squared. The second term will be twice that in front of x, so 2ax. And then the last term is just this number multiplied by itself, so a squared. All right, so it says, number 3 says use the pattern that you discovered to explain without calculating why 100 squared is not equal to 93 squared plus 97 squared, or plus 7 squared. All right? So one way we can explain it is we can say that we know that 93 squared plus 7 squared (100 squared) is actually, some of you probably noticed that it would be 93 plus 7 squared is the same as that. And if you look at our results from the last problem, we're going to end up with 93 squared plus these two things added together and then multiplied by 2. So we're going to have 2 times some number here and then plus 7 squared. So we're missing a big part. And if we say that it's equal to 93 squared plus 7 squared, we're missing a big part of the number that would add up to that. So 100 squared is actually quite a bit greater than that. All right, let's look at another pattern where we have subtraction instead of addition in there. So we can expand this, and we can use the idea that we just got on the last problem. So what we can do is just take x squared plus, and in the last problems we had this number doubled, so minus 2x, and then the last term was this number squared. Negative 1 squared is 1. Or we could just write x squared minus 2x plus 1. So, and just to check that, if we expand this expression like this, and we use one of our methods that we learned, like FOIL method or whatever, if we multiply x times x, we get x squared. If we multiply x times negative 1, we get negative 1x. If we multiply negative 1 times x there, we get negative 1x again. And if we multiply negative 1 times negative 1, we get plus 1. And those two simplify to negative 2x. All right. So I'll just do this first example for you. We can use the same idea. The first term is going to be m squared, of course. And if we think of negative 9 and double that, we get negative 18m. And then if we multiply negative 9 by itself, we get positive 81. Go ahead and let you do the other two. So it says, what is expansion of x minus a squared? X squared is the first term. The middle term is going to be 2 times a times x. And the last term will be plus positive because we have a minus, negative times a negative, which is positive. And if we were to make a rectangle diagram for that, that would look like this. So we have x minus a, x minus a. We get x squared there, minus ax there, minus ax there, and plus a squared there. And these two we can add together and they make minus 2ax, so that matches that. All right, we can generalize on these ideas by just picking any number for a and any number for b, and when we do that, we get a squared for the first term, b squared for the last term of the trinomial, and the middle term is just 2 times a times b. And the only difference between when we're adding them and when we're subtracting them is this middle term, instead of positive 2 times ab, it's negative 2 times ab. So we can use that idea and just, we know that the first term is going to be that term squared, and I'm just going to write it out, and I'll come back and simplify it in a second here. The middle term, since this is a plus, is going to be plus 2 times a, which in this case is 3m, times b, which is 2. And the last term in the trinomial will be the second term squared, which is 2 squared. And then just simplify what we have here. 3m squared, 3m times 3m is 9m squared. 2 times 3 times 2 is 12m. And 2 squared is 4. I'll do one of these subtraction ones with you, and then we can do the other ones in class. How about this one? So I'm going to start by doing this number squared plus 2 times the first number times the last number. Oops, that should be a minus because there's a minus in there. So minus 2 times 2m times 4n. And then the last term is plus, but 4n multiplied by 7. And if I simplify that, I get, this is a second power here. 2m times 2m is 4m to the second. 2 times 2 times 4 is 16. Then mn plus 4m times 4m is 16n squared. All right, I think I'll end the lesson there, and we'll work on this a little more in class. And I'll see you tomorrow.